Sige, let us start. We have here an introduction to organic chemistry. By the way, the book na gagamitin namin ni Ma'am Perlado is this one, The General Organic and Biochemistry 9th edition by Dennis Ton K. et al. Where is my pen? I'm looking. Ayan. Okay, sige, let us continue. For our learning objectives, we will be differentiating organic and inorganic compounds, and we will be identifying the different functional groups and apply the basic rules of the IUPAC in naming organic compounds. If you can still remember, during sa prelim and sa midterm, we actually learned how to name inorganic compounds. So inorganic compounds like ionic compounds, it's a combination of metal and non-metal. Kung naalala niyo pa yung mag-end sa IDE, yung second element. And we also have polyatomic ions for inorganic compounds. But in organic chemistry, we have a different set of rules sa pag-name ng mga organic compounds, and that is set by the IUPAC. And at the same time, we will be drawing structures that will represent alkanes and cycloalkanes. These two are types of organic compounds. If the inorganic compounds have the ionic and the molecular, yung non-metal plus non-metal, this time we have a lot of types ng organic compounds. So meron tayong mga functional groups. Example niyan ay alkanes and cycloalkanes. So we will be naming them, and at the same time, we will learn how to draw their structure. So please listen, class, because this one is a bit difficult compared to inorganic chemistry, and you really need a background of organic chemistry in your biochemistry in your second year para hindi tayo mahirapan sa biochem. And remember, if you have plans to pursue medicine, if you want to be a doctor someday, biochemistry is very important. But in learning biochemistry, you need to establish first your foundation sa organic chemistry. So I hope you are listening there. Bisag magkaon mo, okay lang. Basta naminaw mo, and then you can ask questions later if you are confused about something. So let's start. During the prelims, I already told you what organic chemistry is. This is a branch of chemistry that deals with the study of carbon and all the compounds that contain carbon. So again, all compounds containing carbon will be studied under organic chemistry. And remember, why is this very important? Because the living organisms, syempre including us, our primary constituent sa human body is actually organic compounds. So we have a lot of carbons in our body. And then sub-level, this one, organic chemistry is a sub-level of chemistry that deals with reactions and elements that make up life. So human body is made up of carbon. Therefore, when we are talking about organic chemistry, we are talking about life. We are talking about the reactions that take place inside our body, including other elements na kasama ni carbon. So that is organic chemistry, class. I will just give you some examples of compounds which contain carbon in their structure. These are the examples. So as you can see, this is not a simple compound like sodium chloride that we have NaCl. This time, this is a bit complicated. We have here organic compounds just like ethylene. We have the structure. Yung katabi niya, class, it's the structure of ethylene. So you have two carbons with double bond. They are joined together by double bond. So ethylene is a gas. Ito yung ginagamit in the ripening of fruits. So yung sinasabi nilang kinakalburo yung fruits class like yung saging. Okay, they subject that actually to ethylene. It's a carbon-containing compound. We also have a gas called acetylene. Their difference is the ethylene is bonded with a double bond while acetylene has triple bonds. And then we also have benzene. Take note of the structure. This one is actually 6 hexagon, so 6 na sides. Toluene and the xylene, they are also carbon-containing compounds. I'll be discussing how this is made pag makaabot na tayo sa mga aromatic compounds natin. So they are also used as solvents in the laboratory. And then we have the formaldehyde. You have here the structure. HC double bond O. H, remember formaldehyde is our formalin. We use that one to preserve tissues or the bodies of the cadaver. That's formalin or formaldehyde. And then we have the formic acid, which is a byproduct of the metabolism of alcohol inside our body, not the ethanol that people drink, no, na di ba ang alcohol iniinom siya. We have a lot of alcoholic drinks, however yung iniinom, take note, it's the ethanol, or we simply call that as ethyl alcohol. But I'm not saying that the one that we use as disinfectant like the Green Cross or whatever brand that we have in the market, we don't drink that. We process the liquor, but the one that we use as disinfectant and iniinom natin, parehas yan, ethanol or ethyl alcohol. We have another alcohol which is called methanol, and this one is used as solvent in the laboratory, but we don't drink this. Ito yung, if naalala nyo, may mga balita dati na uminom ng lambanog. Ano sa Bisayang lambanog? Tuba. Uminom ng lambanog and na poison, maraming namatay. So that is due to the contamination of lambanog with methanol. So again, methanol is a type of alcohol that we don't really drink because inside the body, it will become formaldehyde. I have mentioned a while ago. What's the use of formaldehyde? That's preserving tissues and body parts or even the body of a living organism. Now, further degradation, further metabolism of formaldehyde in the body will become formic acid. So ito na yon. Magkatabi sila ni formaldehyde. This is formaldehyde, this is formic acid, and formic acid can actually be poisonous and it can even cause blindness. So if maalala niyo yung balita, sumakit yung tiyan nila after drinking the lambanog, some were even dead after some time, yung iba na hospital lang. Okay? Lahat ng tuba may methanol? No. Tuba actually, diba, is from coconut and then it will be fermented. After fermentation, it will actually produce ethanol. So kaya yan yung iniinom, the ethanol. However, the problem is during the process of making ethanol, I think as far as I can remember, the one in Laguna, there was methanol contamination. So contamination lang siya. Hindi talaga siya deliberately inad doon sa lambanog, but I think it was accidentally mixed with methanol. That is why they were poisoned. They were intoxicated. So again, hindi lahat ng tuba merong methanol kasi hindi talaga natin iniinom class si methanol. But we have a lot of methanol in the laboratory. We use that as solvent if ever meron tayong reactions na or experimentations, procedures na ginagawa sa laboratory. So yan yung magiging metabolism ni ethanol in the body. Magiging formaldehyde siya first and then it will become formic acid that will cause the blindness. And then we also have the phenol. This one is another solvent in the laboratory, but we actually use this one as disinfectant. Actually, the Lysol is a derivative of phenol. So, di ba Lysol brand lang yung Lysol, pero actually yung content niya is a derivative of phenol. So, we use that as disinfectant. Other solvents in the lab, we have aniline, the styrene, and this one, the acetaldehyde, is actually the product of metabolism of ethanol, acetaldehyde. And this one causes hangover. So I don't know if you have tried drinking alcoholic drinks, but when you say you have hangover, it actually means that the ethanol na you drank is metabolized already in the body and you are experiencing the effect of acetaldehyde, just like headache and then flushing. Flushing means you feel hot. You feel hot, imuhang lawas hot, and at the same time there will be redness. So mamula ka. Those are signs of hangover, and that is due to the presence of acetaldehyde, a product of metabolism of ethanol. And then further degradation or metabolism of this acetaldehyde in the body will give you the acetic acid. So this is now the acetic acid, but you can see acetic acid in the urine na. So maihi mo na siya after. But acetic acid, aside from being a degradation product of ethyl alcohol, this one is the acid that is in our vinegar. So pag makikita kayo ng COOH class like this one is actually an acid. So sa ano kasi, sa inorganic chemistry, when we say acid, we have the hydrogen, right? Like hydrochloric acid, nitric acid, sulfuric acid, but you don't see carbon there. In organic chemistry, we also have acids class, but they contain carbon. And yung functional group nila is COOH. If you see COOH, it means it's an organic acid. Okay? And then acetone also is an organic compound. So this is the chemical structure or chemical formula of our acetone. So for girls, we use acetone, right, as nail polish remover. But you cannot see acetone being sold in the market in large quantities because this is being regulated by PDEA. Kasi acetone is used to make prohibited drugs like the shabu or the methamphetamine. So again, yung ano lang, pinapabili sa market is actually very small. So, small quantity of acetone only. Kasi pag nahulihan kang you have a large quantity of acetone and then you don't have the proper permit from the FDA and the PDEA, pwede kang makulong class kasi it's one of the chemical used in making shabu. And then we have benzaldehyde and benzoic acid that are used in as preservatives. So like sa food or other pharmaceutical drugs or mga substances natin that need to be preserved, pwede silang merong benzoic acid or benzaldehyde because that too are preservatives. Any questions so far about our examples of organic compounds? Questions or clarification? Example lang ito ha. By the way, ethanol and methanol are also organic compounds. They also contain carbon in their structure. Wala? Wala'y pangutana? Okay. So let us continue. Let us draw an electron dot diagram of carbons. We are not yet done with the electrons, no? Remember, we have subatomic particles, protons, neutrons, electrons. But the one that is unique and the cause of any reaction is actually the electron. So let us look at the electron of our carbon. Kasi this is the center of organic chemistry, carbon. Now, carbon belongs to group 4 in the periodic table, which means that it has 4 valence electron. So I hope you can still remember what valence electron is. Valence electron or electrons are the electrons found in the outermost shell. So di ba meron tayong mga orbital or mga shells for our atoms, and the last shell there is called the outermost shell, and the electrons found there are called the valence electrons. So for carbon, meron yan siyang 4 na valence electrons class. So 4 yan lahat. Okay? And now, these 4 electrons can actually form bonds with other elements. It can be another carbon or another element. But again, these 4 carbons, 4 electrons has the ability to form bonds with other elements. So that's how unique carbon is. In organic chemistry, we learned there that there is transfer of electrons between, example, metal and non-metal. There will be transfer of electrons. But this time in carbon, ang ma-form na bond is covalent bond, which means there will be sharing of electron. Walang magta-transfer. Remember that the redox reaction, oxidation, and reduction, magkakaroon ng transfer of electrons, merong changes in the charges. Diba yung iba from +2 magiging 0, from 0 magiging +1. So redox reaction, there is transfer of electron. That is true for inorganic compounds. But for organic compounds, these 4 electrons will be shared to another element. Ito yung uniqueness ni carbon. So if these electrons are being shared, the bond that will be formed is called the covalent bond. It's a link. It's a bond between 2 atoms or ions wherein the electrons are being shared. They are not transferred. They are shared with one another. So other name of covalent bond is molecular bond. And saan nagta-take place sa covalent bond? Covalent bonds are formed between 2 non-metal atoms. Again, 2 non-metal atoms before you can have the covalent bond. Therefore, you cannot see covalent bonds class between a metal and a non-metal. Ang requirement, non-metal and a non-metal. So for example, you have carbon. Carbon is a non-metal. If it bonds with oxygen, then there is a covalent bond that will be formed. And they will have close electronegativity values. So in your periodic table, the one that is being bought no, na periodic table, not the one na pinagawa ko sa inyo sa prelim. Kasi yung pinagawa ko sa inyo sa prelim, it only contained atomic number and atomic mass. But if you have there your periodic table, you can see a lot of numbers there aside from the atomic number and atomic mass. And one number that you can see there is the electronegativity values. So that number is actually representing the ability of the element to attract electrons. So if it has a large value, meaning it has the ability to attract electrons from other elements. Now, if these 2 combining elements have close electronegativity values, then the possibility of forming a covalent bond is also high. So, yan yung palatandaan, pero we don't really dwell on electronegative values anymore. Just take note that if 2 non-metal elements are combined together, they can form covalent bonds. So they will not be transferring electrons. Instead, they will be sharing their electrons. So we have here characteristics of organic compounds. So our organic compounds are actually non-polar compounds. Therefore, they don't dissolve in polar solvents like our water. So this is just like water and oil. Remember that water and oil do not mix with each other. That is also true for our organic compounds. You cannot mix water with organic compounds because the water is polar and the organic compounds are non-polar. So hindi sila magmi-mix together. Remember the rule in chemistry, like dissolves like. Now, for you to wait lang ha, let me write on the screen. For you to understand what's the difference between non-polar and polar is, let us have the following example. This is water, H2O. Let me draw it again, H, and then this is O, and then we have H. Anong nakalagay dyan? Water is a polar substance. When you say polar substance, class, it means that there is an equal sharing of electrons. Again, an equal sharing of electrons. Polar yan siya. Pero pag sinabing non-polar, just like our organic compounds, there will be equal sharing of electrons. So let me give you an example. Carbon tetrachloride. Okay. You have here a carbon. Remember, atong mga organic compounds have carbon. So yes, we have carbon on the screen. Carbon tetrachloride means meron siyang 4 na chlorine na nakapalibot sa kanya. The name is, syempre this is water, and then this one is carbon tetrachloride. Okay. So ano nangyari? Sa polar, there is an equal sharing of electrons. So ang electrons na titingnan natin is yung nasa outermost shell lang. It will be the valence electron. And that will be represented in the group or the family where they belong in the periodic table. So remember that hydrogen is found in the group 1, which means it has 1 valence electron, and that is also true for another hydrogen here. But take note that oxygen belongs to the group 6. So meaning pag group 6 siya, it has 6 valence electron. So you have 1, 2, 3, 4, 5, and 6 on the other side. Therefore, if this combines to form water, hydrogen will share its electron, 1 electron to oxygen, and then this electron here will also be shared. Mag-share yan sila. To form bonds, you need 2 electrons ha, para ma-form yung bonds. So itong electron ni hydrogen will be shared to electrons ni hydrogen will be shared to oxygen to form the covalent bond. Now, asan dyan ang unequal sharing, ma'am? Remember that si hydrogen, nag-share siya ng isa. Itong isang hydrogen na ito, nag-share din siya ng isa. But ilang electrons lahat yung na-share ni oxygen? It is 2. 1 on the other side, 1 on the right side. So, hindi equal. So, there is an equal sharing of electrons. Ang tawag natin dyan, class, polar. So, kung makarinig kayo na it is a polar substance or a polar solvent, it just means that there is an equal sharing of the electrons. So polar, yung water natin is a polar solvent and it can only dissolve polar solutes also. Aside from the ionic compounds ha, ionic compounds has nothing to do with this. Pag ionic compounds, most of the time, they are soluble in water. But if we are talking about organic compounds, for it to be dissolved in water, it should be polar also. Meaning, if you look at the electrons, there will be an equal sharing of electrons. So, and then meron tayong at the same time sa oxygen kasi class, merong matitira dyan na electrons, hindi na share. Merong hindi na share na electrons. So merong natira. Hindi equal yung sharing. Si hydrogen, ubos yung kanyang electrons na na-share. Itong hydrogen dito, ubos din. Pero sa gitna, anong nangyari? Merong tigdadalawa dyan na natira on both sides. Now, let's look at carbon tetrachloride. So, si carbon tetrachloride here, wait lang. What are the examples of polar solute? What are the examples of polar solutes? Actually, si ionic compounds, though soluble sila sa water, they can be considered polar actually. Pero ionic kasi sila, no? So let us try to see kung ano yung mga polar. The sugar. The sugar class, table sugar is actually a polar na solute. So it is very soluble in water. Kanang asukal na ato ang ginagamit. However man good, it is a very big compound. So remember that sucrose is C11H22O11. So murag lisod-lisod ipakita ang ato ang sharing of electrons for that. Kasag daghan kaayo ta og elements. C11 ka carbon, 22 ka hydrogen, og oxygen 11 pod. But take note that it is an example of a polar solute. There is an equal sharing of electrons. Therefore, kaya niyang ma-dissolve sa water class. Pagdating kay non-polar, itong kay carbon class, you have 1, 2, 3, 4. Ayan, you have 1, 2, 3, 4. Ito kasi ang mangyayari sa kanila, chlorine will share 1. Ito din, chlorine will share 1 here. And chlorine also, lahat silang chlorine class mag-share ng tag-iisa kay carbon. So there will be equal sharing. In terms kay chlorine kay chlorine. There will be equal sharing of electrons here. Mabubuo si chlorine. Kasi si chlorine kasi 7 ang kanyang 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. And then, si chlorine class 7 ang kanyang valence electron. So, meron siyang matitira dyan. Yan yung isi-share niya kay carbon. This is also true for the other chlorines. And ang mangyayari sa carbon tetrachloride natin, wala tayong extra electrons. Hindi kagaya kay oxygen dito na unequal. Stable si hydrogen, stable si hydrogen dito, kompleto siya, pero si oxygen merong mga extra kaya unequal yung distribution ng ating electrons. This time kasi, ang mangyayari kay carbon tetrachloride, magiging stable silang lahat. Remember the octet rule na kailangan 8 electrons sila para maging stable. So lahat sila na puno. Mag-share siya ng isa dyan, mag-share din ito ng isa-isa. So equal sila ng shinare na electron kay carbon, pero silang lahat class magiging stable. And si carbon sa gitna, wala siyang magiging extra electrons. Hindi kagaya ni oxygen na meron siyang extra electrons sa gitna. Ubos lahat ang kanyang electrons na na-share sa lahat ng chlorine. So wala kang makikita na ganito na electron sa kanya. Si carbon dyan, lahat ng kanyang electrons na share niya with the elements, which is chlorine. So there will be equal sharing of electrons when you say non-polar na substance or compound. Hindi siya kagaya ni water. Meron tayong floating electrons here. Ito lahat, they are being bonded. They are being shared. So wala kang makikita na electrons sa gitna. That's the difference between polar and non-polar. So again, our polar solvent is water. And water is our universal solvent, no? So it can dissolve ionic compounds. When you say ionic compounds, it's the metal plus the non-metal. But it can also dissolve polar solutes. If we will just draw everything, makikita natin yung mga electrons like ni table sugar. There will be an equal sharing of the electrons between carbon, hydrogen, and oxygen there. So pwede siyang ma-dissolve sa water. Pero kapag equal ang distribution ng ating electrons, non-polar ang tawag dyan. So wala kasi siyang polar na side. Ito kasi merong mga sides na polar. Kaya when you say polar kasi, meron talagang electrons dyan na floating. So hindi equal yung pag-distribute ng electron. Ito kasi equal. Wala kang makikitang extra electron dyan. Lahat banded. So, yan yung mga non-polar compounds natin. And ano lang, like dissolves like. So, non-polar solute will also dissolve in non-polar solvent, just like the carbon tetrachloride. Ang tandaan nyo lang, basta organic compounds, most of them are non-polar. So, we don't dissolve them or mix them together with water. Aside from that, another characteristic of an organic compound is they have low melting point. Madali silang mag-melt. Okay? Kung sa Bisaya, papaspas sila mag-melt. If we have an organic compound na solid, i-subject natin siya into heating, then mabilis lang yung pag-melt niya. Mag-melt siya agad, even in low temperature. So that is due to actually low or weak intermolecular forces. Pag sinabing intermolecular forces, class, it's a bond between one molecule to another molecule. So you can have here this one. Example, you have one molecule here, a carbon to carbon molecule. That's one molecule. This is molecule number 1. Now, we have another molecule here. Wala lang yun niya siya na shoot class, but this one is another molecule. It's another carbon to carbon molecule. And if they are being mixed together, they will be combined through an intermolecular force. So again, intermolecular force is a bond between one molecule to another molecule. But for organic compound, the intermolecular forces are weak. Therefore, pag i-subject mo siya sa heating, madali itong ma-break. Itong bond na ito, class, madali ma-break. Kaya madali sila mag-melt. Yan yung ibig sabihin ng low melting point. So this one here, itong that is actually the intermolecular force connecting the molecules. But kung titingnan natin, may nakalagay dyan strong. Yung strong na yan, ito yan. The bond between carbon and carbon. This one is called the covalent bond. I hope na intindihan nyo ang difference ni intermolecular force and the covalent bond. The covalent bond, this is one molecule here, and it's in the molecule between carbon and carbon. So sa molecule mismo ang tawag dyan covalent bond pag if it is non-metal plus non-metal, and covalent bond is actually a strong bond. So it is not easily broken. So ito din, carbon to carbon bond dyan, may covalent bond, it's a strong bond. Pero if it is between one molecule of this carbon to carbon and another molecule of this carbon to carbon which contains covalent bond. It's called intermolecular force and it's a weak bond. So, pag madali siyang i-break, especially when you subject that to heating, mo na siya mag-melt siya dayon. Okay? Now, they react slower than ionic compounds, and that is due to strong covalent bonds between our atoms. So, nakita natin na siya sa illustration a while ago. This one, you have covalent bonds connecting the carbon and the carbon. So, one atom to another atom, covalent bond in between. And since this is a strong bond, the result is there will be slower reaction. So in the laboratory, actually, in the prelims and in the midterms, we discussed inorganic compounds, and I think I had pictures of procedures in the laboratory where you can see, example, there is formation of the precipitate. So when you mix together one inorganic compound to inorganic compound, makikita mo agad, visible ka agad yung reaction. There can be changes in the color, or there will be formation of the precipitate, or there will be evolution of gas. So agad-agad makikita mo yung evidences that there is really a chemical reaction. But for organic compounds class, again, for organic compounds, the reaction will be slow. So, hindi mo agad makikita yung mga evidences na there is really a chemical reaction. Because again, the bond between atoms for organic compounds are strong. Covalent bonds are strong. The result will be a slower reaction compared to the ionic compounds. So, yun yung mga characteristics ng ating organic compounds. Questions so far about the characteristics? Wala. So let us continue. So why are there so many organic compounds? Marami tayong masyadong organic compounds class. Actually, we have more organic compounds compared to ionic compounds. Our ionic compounds are actually limited. Kasi hindi naman lahat magre-react with other elements, and we have noble gases pa na hindi talaga nagko-combine with other elements. So limited yung inorganic compounds natin. But the organic compounds, because carbon is very unique, marami tayong masyadong organic compounds. And what are the reasons bakit marami tayong organic compounds? Number one, carbon can form stable covalent bonds with other carbon atoms. So again, si carbon, kaya niyang mag-combine sa kapwa niya carbon. And that the bond between a carbon and another carbon is covalent bond, which is a strong bond. That is why it is stable. It is not easily broken. Okay? Carbon to carbon. Ang tawag natin dito class is catenation. If you hear the word catenation, it means it's the ability of carbon to form bond with itself, meaning kaya niyang makipag-combine with another carbon. Hindi kapareha class ng mga metals natin like sodium. Sodium cannot really form bond with another sodium. So unique si carbon kasi kaya niyang mag-form bonds with kapwa niya carbon. That is the reason why carbon has several allotropes. When you say allotropes, these are substances that has same composition. When you say same composition, same yung element niya na nag-combine together, but it has different physical or even chemical properties. So let us have an example of the allotropes of carbon. Example, the diamond. The diamond is one of the hardest mineral that we have. Dati, it is the hardest good, number one. You cannot break diamond if you don't use kapwa niya, diamond. That's how hard diamond is. Pero nowadays, meron na silang na-discover na mas hard pa kesa kay diamond. So hindi na siya hardest nowadays, but it's still one of the hardest minerals. So si diamond actually, class, I don't know if you have seen an actual diamond, na totoo talaga na diamond. It is just actually made up of carbon. Carbon lang yan siya lahat, bonded together with itself. So isa siyang allotrope ni carbon. Maraming carbon na nag-bond together. So na-form si diamond. And it's very hard. Okay? It's an allotrope. It's an allotrope of carbon. So carbon lang yung lahat ang composition niya. But as you can see, it is very hard. But we also have the graphite. The graphite is yung, example niyan, yung lead of our pencil. Ang ginagamit natin pang sulat sa pencil natin, the tip, is actually a graphite. And it's still made up of carbon. So carbon bonded together with other carbons. So pareha sila ni diamond, same ang composition nila, carbon lang lahat, but they have different physical and chemical properties. Diamond is very hard, while graphite naman is one of our softest metal, or sorry, not metal, mineral. Okay? So magkaiba yung kanilang properties. Questions about allotropes? Wala. Aside from the graphite, actually we have the charcoal. Uling. The charcoal is also made up of carbon. Carbon lang lahat. But as you can see, it has a different property with that of the diamond and even the graphite. So that is the reason why that we have many organic compounds, because carbon is really unique. It can form bond with itself, and the resulting substance will have a different property, either physical or chemical property. Okay. Number two reason why we have a lot of organic compound is carbon can form stable elements with other elements. So it's not just between carbon and another carbon. Carbon has also the ability to form bonds with other elements, just like oxygen, sulfur, nitrogen, and even chlorine, as what I gave you a while ago, the carbon tetrachloride. So carbon can also form bonds with chlorine. So kaya marami tayong organic compounds. And as at this same time, class, carbon can form double or triple bonds with other carbons to produce another set of organic molecules, and at this time, iba din ang kanyang physical and chemical properties. Meron tayong carbon-to-carbon single bond. We also have carbon-to-carbon double bond. And we also have carbon-to-carbon triple bonds. So ito, they have carbons lang yung composition nila, but they will have different properties. So it's a different molecule now. So this will add up now to the number of organic compounds that we have na nag-e-exist. So kaya meron talaga tayong separate study for carbon alone. Kasi again, it's very unique. When we studied inorganic compounds class, I cannot remember that I gave you an example na merong triple bonds or double bonds sa mga inorganic compounds natin. So wala sila nag-exist. It's actually unique for carbon. Well, hydrogen can actually form triple bonds with itself, but it's actually carbon that is very unique when it comes to the bonding. Okay, questions before we'll move on to the families of organic compounds. Na? Kailangan dyan na ito ang organic compounds ha, kasi This is talking about life, and you will have your biochemistry in your second year. Second year pa kasi ang second sem by January, it will be analytical chemistry. So anachem muna before biochem. But si anachem is more on computation kasi analytical chemistry. So you will be analyzing chemicals for that. I don't know if you will be included in the limited face-to-face by January, but if you are included, you will have your laboratory experiments in anachem. So in your second year, you will have your biochem, and you need these organic compounds. So let's have the families of organic compounds. We have the first one, hydrocarbon. Pag sinabing hydrocarbon class, from the name itself, you will only see hydrogen and carbon. That's number one. Number one na family sa organic compounds natin. Hydrocarbon. So if you look at its structure, you will only see carbons. Kahit maraming carbons pa dyan, as long as carbon and hydrogen lang talaga. But we also have substituted hydrocarbons. Instead of having carbons and hydrogen, you will see one of the hydrogens will be substituted or replaced by another atom or group of atoms. So let me give you an example. The hydroxyl group. So 'di ba, meron tayong carbon and hydrogen. Example, isang carbon lang. So since si carbon meron siyang 4 na valence electron, it can bond up to 4 hydrogen. This one is a hydrocarbon because ayan, hydrocarbon siya because you will only see hydrogen and carbon there. But if it is a substituted hydrocarbon, so like this one, so instead of having 4 hydrogen, 1 hydrogen will be substituted by an atom or a group of atom. An example of a group of atom is the hydroxyl group. So you will place here OH instead of the H. This one is now a substituted hydrocarbon. So this is actually your methanol. Methanol is an alcohol. It contains OH. Pag it contains OH, it's an alcohol. So alcohol is a substituted hydrocarbon. Okay? Or you can also have C, H, and instead of the hydrogen, you can also replace it with a carboxyl group. We call it COOH is called carboxyl group. So you will have COOH here. So hindi na siya totally hydrocarbon lang talaga. Though you can see hydrogen and carbon lang gihapon, no? Pero substituted. One hydrogen is substituted by another group of atom na. Hindi na siya purely hydrogen lang dito. So this is another example of a substituted hydrocarbon. This time, mayroon siyang COOH. This is actually your acetic acid, the acid you see in vinegar. Okay? So that is the difference between a hydrocarbon na lahat ng nakaband kay carbon ay hydrogen lang talaga, and the substituted hydrocarbon where one or more hydrogen is being replaced by another atom or a group of atoms. Now we have the so-called aliphatic hydrocarbon, and the examples of functional groups in this family of organic compounds are the alkanes, cycloalkanes, alkenes, and alkynes. Ano ang pangalan sa ato ang mga organic compounds ha? Alkanes, cycloalkanes, alkenes, and alkynes. What is their difference? Pag sinabing alkanes class, you will just have carbon to carbon, single bond. Kahit maraming carbon pa yan siya, but you can only see single bonds between the carbons. We call it alkanes. So methane is class C, 1 carbon and then bonded to 4 hydrogen, it's a hydrocarbon. But if you will add another carbon and it's a single bond in between, then that will be an alkane, just like this one, ethane. And then if you add more carbon pero single bond pa rin, like this, tatlo na yung kanyang carbon, we call this propane, it's still class an alkane. So ito lahat sila are alkanes. But kapag ka naging ring class yung ating carbon to carbon na bonding, ito kasi ano lang siya, parang linear lang siya. Pwede kang mag-branch here, pero pag hindi ka nag-form ng ring, alkanes lang talaga ang tawag dyan. Pero pag nag-form na siya ng ring, kagaya nito, ayan, nag-form na siya ng ring. Meron kang actually carbon dyan sa mga intersections, pero single bond pa rin siya. Ang tawag dyan, cycloalkanes. Nag-form na siya ng ring. So even if like this one, you'll have a square, you'll have carbon in the intersections, this is still a cycloalkane kasi single bond pero it formed a ring. But if meron na siyang double bond class, carbon to carbon double bond, ang tawag dyan, alkenes. Okay? Again, pag meron na siyang double bond, alkene na ang tawag dyan. So for example, this one, carbon to carbon double bond, or meron kang this one, kahit meron ka pang presence dyan ng isang single bond, pero meron ka nang makikita na double bond, automatic this will be an alkene. So pag isa lang, alkane, pag dalawa, alkene. Pero pag naging tatlo na, we call that alkyne. Okay, alkane, alkene, and alkyne. I hope you know the difference now between the three. Pag it forms a ring, it can be cycloalkane, cycloalkene, or cycloalkyne. Pag nag-form na ng ring. Okay, questions? Wala? May pangutana? Kasi nabot bataan na. Wait lang ha. Okay, and then we also have the so-called aromatic hydrocarbons. Pag aromatic hydrocarbons, they will have the ring. Again, they will have the ring, but most of the time, there will be a presence of the benzene ring. Again, we have the benzene ring here. Pag merong benzene ring, magiging aromatic hydrocarbon na siya. Benzene ring and its derivative. Actually, for the aromatic hydrocarbons, we follow the Haeckel's rule. The Haeckel's rule. This is how we know if the hydrocarbon is aromatic or not. Meron tayong formula for this. It's 2n, wait lang ha, I forgot 2n plus 5. Let me check if I remembered it correctly because it is not included in the, where is it? Oh, wait. It's on the other slide kasi that I made. I was not the one who made this slide kasi, so it was not included. So the Haeckel's rule, yeah, it's 2n plus 2. (2n plus 2 equals pi electron. 2n plus 2 equals the pi electron. So kasi, di ba, meron tayong tinatawag na cycloalkane, alkene, and alkyne. So para ma-differentiate natin between the cycloalkane and the aromatic hydrocarbons, we actually compute 2n plus 2 equals the pi electron. Kadjut lang ha. Let me check if I really remembered it correctly. Or should I just use my slide for this? Para dili ka maglibog. And I'll give you an example. Pharmacism. Organic chemistry. Sabak kayo kung cellphone. Okay, let's use my slide. Where is it? Ah, this one. Sorry, it's not 2N, it's 4N. Let me check that. Ulit. Ayan. This is the Huckel's rule. It's 4N plus 2 equals pi electron pala. Okay, this is used to determine if a compound is aromatic or not. Now, isosolve natin siya. If N is a whole number, then the substance is aromatic. But if it is a fraction, then it can just be a cycloalkene, alkyne, or cycloalkene or cycloalkyne. So this one, let us have the benzene first. We know that benzene class is an aromatic hydrocarbon. Ito kasi ang totoong chemical formula ni benzene. So pag magko-compute tayo, ganito lang siya. 4N plus 2 equals, itong pi electron are the electrons found in the double bonds sa structure. So itong mga linya na ito, this will denote na merong double bond dyan. And one side of this has one electron, the other side has another electron. So i-ano lang na siya, bilangon, pila tanan, 1, 2, 3, 4, 5, 6, meaning meron siyang 6 pi electrons. So ilalagay mo siya dito. So again, alin ang bibilangin? This one. Ang mga ending ng ating double bond. So 1, 2, 3, 4, 5, 6. Okay? And then magko-compute ka na. 4N plus 2, ay, sorry, diulit lang ako siya. Let me erase that one. Ang gagawin natin dito, itatranspose ito sa kabila. So this will become 6 minus 2. So 4N equals 4. 6 minus 2 is 4, right? And then divide both sides with the 4. So N equals 1. So anong sabi? Pag ang N is a whole number, then it is aromatic. So since 1 is a whole number, therefore benzene is aromatic. It's not a cycloalkene. Aromatic siya. Now let's have another example. Paano ma'am kung meron ganito? Ayan. Square siya ha. May mga carbons yan siya dyan sa bawat intersection. And then may makita ka na double bond here. Yan, may double bond siya. Pero you are not sure if this is aromatic or just a cycloalkene. So you can use this formula. So magfo-4N plus 2 equals pi electron ka na naman. You'll have 4N plus 2 equals, yung pi electron, bilangin mo. So sa double bond ka lang magbibilang ha. So you will have 1 and then 2 on the other side. So the pi electron here is 2. 4N is equal to 2. Lipat natin sa kabila yung 2. So this is 2 minus 2. 4N is equal to 0 divided by 4 both sides. Syempre, this is equal to 0. 0 is not included sa whole number class ha na tinitingnan natin. So since this is not a positive integer and a whole number, then ito class is not an aromatic compound. This is just a cycloalkene. Okay? This is actually named as 1, 2, 3, 4. This is 1-butene. Ay, dugtong na ha. Sige. Malayo kayong space. So this is just named as 1-butene. This one is named as benzene. Pero imog ka hadlo ka I'll teach you how to name organic compounds. Ito pa lang, this is just the process of knowing whether a substance is aromatic or not. Aromatic ba siya or alkene lang siya? Ano? Or alkyne. Okay, questions about the Huckel's rule to determine if aromatic or not yung ating hydrocarbon? Wala. Buhi pa ta. Bisig natulog na. React daw be kung naminaw pa. Ang wala nag-react, natulog na yun, diba? Yung mga wala nag-react, asa ka na sila? Okay. Sige. Question so far about this. Ay, mali. Wala, kaya pa. Okay. So yun ha. Kasi meron tayong aliphatic hydrocarbon ng mga cycloalkenes. Kapag ka nag-form na siya ng ring, pwede siyang cycloalkane, cycloalkenes, or cycloalkynes. Pero, according to Huckel's rule, meron tayong tinatawag na aromatic hydrocarbons which contain benzene or benzene derivatives. So if you are not sure whether it is really an aromatic hydrocarbon, then just compute. You have to get a whole number, okay? A positive integer, a whole number. Now, when you say functional groups class, this is actually an atom or group of atoms that is arranged in a specific order, and that will be responsible for the identity of the organic compound. Again, meron tayong tinatawag na functional groups. And when you say functional groups, they are atoms or group of atoms combined together in a specific arrangement. Okay, pag makikita natin yung specific arrangement na yan, that will now give the identity, including the physical and chemical properties of the compound. So functional groups are used for identification. And what are the examples of the functional groups that we will learn in organic chemistry? Medyo daghan-daghan ha. So i-prepare lang ang self and kailangan mag-study yun ani wholeheartedly. Mo ni siya ang mga functional groups nato. We have first the alkane. How to detect that a compound is an alkane? You will just see carbon to carbon single bond. So alkane is a hydrocarbon. You will just see carbon and hydrogen, but the bond between the carbon and another carbon will just be a single bond. Automatic, it will be alkane. Now in the nomenclature, again, in the nomenclature, meaning in the naming, when I'm talking about nomenclature, naming ha, in the naming, you will see the alkane, you will identify the alkane because their name ends with an ane. Again, their name ends with an ane, just like methane. And then butane. Di ba butane, ginagamit natin yan pag nagluluto tayo. So butane is actually an alkane. If we look at its structure, you will see their carbon and hydrogen only, and that the carbon and another carbon is bonded with a single bond. We also have the hexane, heptane, nonane, and so on. But if you see a double bond na, pag meron ng presence ni double bond, it will be called alkene. Okay, alkene na siya. So we have a lot of alkenes existing nowadays. Now, how about their names? You can also identify them because their names end with in. Okay, in na siya. Actually, parehas lang na sila. Parehas sa ethene. Namantay ethane, di ba? Natay ethane. Single bond na siya. Pero pag may double bond na, it will be called ethene. Butane will be called butene. Hexane will be called hexene. And so on. Okay? Now, pag may triple bond na siya, ayan, triple bond na, ang kanyang name will be ending with ine. Okay? It will end with ine. So we have ethyne, butane, hexane, and heptine, and so on. So daghan pa na sila. Basta pag mag-end ilahang name with "ine", it is called alkyne. Or "ine" ang kanyang ending. So tatlo na sila, hydrocarbons, hydrogen and carbon only, and their difference will be the number of bonds. Questions so far? It's 8:54. Wala. Now, the di means dalawa, di ba? We use the prefix di to denote that we have two. Anong two? Dalawang in. Anong ibig sabihin ng in? It's alkene, which means if you see a compound that contains two double bonds, ang tawag sa kanyang, ang tawag sa kanyang functional group ay diene. So just like the example in the screen, you have CH2, double bond CH, single bond CH, double bond CH2. Dalawang double bond, so it's a diene. So in the naming also, you will see their ending na diene. Meaning meron siyang dalawang double bonds. Example, butadiene. Instead of butane or butene, kung double bond, since dalawang double bond niya, instead na butene siya, it will be called butadiene or hexadiene. That's how you name, class, a structure, a compound with two double bonds. So tomorrow, after our quiz, we will continue with more functional groups that we use in organic chemistry. So I hope you learned something this morning, though I believe kung hindi nyo kasi siya nadaanan during your junior or senior high school days, medyo mahirap. Pero iisa-isahin lang natin siya hangtod na makuha ninyo. So do not hesitate to ask question or to clarify something para masabtan yun ninyo siya and okay inyong foundation sa organic chemistry. Okay? Wala yung pangutana before ta mag-end?